This is Stoichiometry tutorial number 5, the limiting reactant. For this tutorial you will need the usual periodic table, calculator, the map of mole land, and the worksheet that accompanies this tutorial. So first we have to talk about the limiting reactant. And so we're going to look at it in an example that does not relate to chemistry, just to get a feel for what this looks like in the real world. So if you have 50 bicycle frames and 80 bicycle wheels, how many bicycles can be made? And so let's process through this right quick. One bike needs one frame, but it needs 2 wheels. So if we have 50 frames and 80 wheels, what would be our limiting reactant? So let's take a look at this one. We're going to use a dimensional analysis to make a conversion. We know that there's one frame for one bike. So we can make 50 bikes out of 50 frames. And then here we know that there's 2 wheels on every one bike. So we could only make 40 bikes with 80 wheels. And so what limits the number of bicycles? Is it our frames or our wheels? So you should be able to see that it would be the number of wheels. And so the number of wheels will limit how many bicycles we can make. Because even though we have 50 frames, the number of wheels limits the number of bikes that we can make. And so then we have excess frames. And so we'll see a calculation later where it asks us to find the amount of grams that are left over. And so you can calculate the excess really easily. For this one, we know that we have 50 frames, but if we can only make 40 bikes, we will only need to use 40 frames. And so that will tell us how many we have extra. And so we have 10 frames extra. So that is our excess. So now moving on, here's the formal definition of a limiting reactant. It is going to be the substance that is used up first. So that will be your limiting reactant. It will limit how much of your product can be made. The substance that is left over after the reaction is the excess reactant. You have more than you need of this reactant. Here are a few steps for identifying the limiting reactant. First, you're going to want to balance the equation. That is always going to come first, especially now that we're using these mole ratios. Then for each of your reactants, you'll be given either the number of grams or you might start with the mole. Either way, you need to convert to the moles for each of those reactants. And this is going to give you the number of moles available. And so you see what you have available. From this point, you're going to use the mole ratio, and you're going to convert moles of one reactant to moles of the other reactant using that mole ratio. So this will allow you to find the moles that are needed. So you see how many you have available, and then you can compare that to how many you need. The limiting reactant is going to be the reactant that needs more than there is available. So if you don't have enough, that means that's the one that's going to limit the reactant. And so you're going to solve the rest of the problem and answer the question that is posed, and it's a really important thing that's not included on this second number 4. You're going to use that limiting reactant to solve the rest of the problem. And then you might have excess of your excess reactant. Looking at the first problem, 3.45 moles of nitrogen gas reacts with 4.85 moles of hydrogen gas to form ammonia. What is the limiting reactant and how many moles of ammonia will form? So first we have to write our equation and balance it. You have nitrogen gas, diatomic, reacting with hydrogen gas, also diatomic, to form ammonia, NH3. Now we must balance our equation. We have 2 moles of ammonia. So this tells us that you have 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. Now the problem here gives us that we have 3.45 moles of nitrogen, and it is going to react with 4.85 moles of hydrogen gas. And so this isn't consistent with the mole ratio. We see that this is in a 1 to 3 to 2 ratio. But here we have 3.45 and 4.85. It's not falling within that ratio, and so we're going to have extra of one of these reactants. So to figure out which one will be the limiting reactant, we have to first convert, and we'll see the moles that are needed. And so since it already provides us with moles, we have here already, this is the number of moles available of N2, and this is the number of moles available for hydrogen. So we have 3.45 moles available of N2. Now let's see how many moles of hydrogen we would need to react with nitrogen by setting up a mole ratio. We see that we have 1 mole of N2 for every 3 moles of H2. Okay, I'll let you get that calculated. So we see that we have 10.35, and our moles of nitrogen are canceling out, so we have moles of hydrogen that is needed. So let's take a quick look and examine this here. We only have 4.85 moles of hydrogen available. We need 10.35. So do we have enough moles of hydrogen available to react with 3.45 moles of nitrogen? Do we have enough available? No. So we don't have enough available there. So that already tells us that this is our limiting reactant. Hydrogen is our limiting reactant. Now just to be certain, let's go ahead and solve for what is needed for nitrogen. So we start with 4.85 moles of hydrogen. And we have 3 moles of hydrogen for every 1 mole of nitrogen. So 4.85 divided by 3, the moles of hydrogen will cancel out. So this lets us know that we only need 1.607 moles of N2 are needed. So as you can see, we have 3.45 moles available, and we only need 1.607 moles. And so here we have excess nitrogen. So we have plenty. So that means hydrogen is our limiting reactant. And so from here on out, we have to use hydrogen to solve for how many grams of ammonia, or sorry, how many moles of ammonia will form. We have to use hydrogen because it will limit how much can form. So let's clear out of this and start solving this second question. So with hydrogen as our limiting reactant, we have 4.85 moles of hydrogen to start with. This is what's available. This is what's going to react. So we need to go from moles of hydrogen to moles of a different chemical. And so that's where we have to use the mole ratio. And so right quick, let me rewrite the equation. So we have to drop down the number of moles of hydrogen, which we have 3 moles of hydrogen. And then mole ratio with ammonia, we have 2 moles of ammonia. So we will stop here. It is a one-step conversion because that's what we want to know. We want to know moles of ammonia, and this has gotten us to moles of ammonia. And so we have 3.23 moles of ammonia formed. That is the answer for this question, using the limiting reactant to find how much will be produced. Next problem, we have 100